U.S. Army tests SMET and Ghost X at Project Convergence Capstone 4. In modern warfare, the U.S. Army is constantly integrating new technologies to improve combat effectiveness and operational efficiency. One of the most recent demonstrations of this was Project Convergence Capstone 4, PCC4, a large-scale military experiment. This event brought together thousands of military personnel and advanced defense technologies to test new warfare capabilities. Among the key systems evaluated were the Small Multi-Purpose Equipment Transport, SMET, and the Ghost X Unmanned Aircraft System, UAS. PCC-4 is the largest joint and multinational exercise ever conducted by the U.S. Army. It was designed to test how new technologies perform in realistic combat scenarios. The main goals were to improve situational awareness, enhance command and control, test autonomous systems, integrate artificial intelligence, and strengthen coalition warfare with allies including the United Kingdom, Australia, Canada, New Zealand, France, and Japan. This experiment is part of the U.S. Army's modernization strategy to ensure future soldiers have a technological edge on the battlefield. One of the key technologies tested was the SMET, a robotic ground vehicle that provides logistical support for troops. The SMET is an autonomous system that can operate on its own or be manually controlled. It can transport up to 1,000 pounds, 450 kilograms, of gear, ammunition, and medical supplies, reducing the burden on soldiers. It also has medical evacuation, medevac capabilities, meaning it can transport injured troops from combat zones. The SMET has a hybrid electric power system, allowing it to operate for long periods and provide power to recharge devices. It is designed to navigate difficult terrain, making it useful in different combat environments. At PCC-4, the SMET proved its ability to enhance unit mobility and sustainment, allowing soldiers to operate more effectively. The SMET is estimated to cost $100,000 per unit, making it an affordable and scalable solution for modern battlefields. Its durability and versatility make it a valuable asset, especially in extended combat missions where traditional logistics are challenging. Additionally, the SMET has been tested for its ability to carry small caliber weapon systems, potentially allowing it to act as an armed robotic support unit in future operations. The Ghost X Unmanned Aircraft System UAS, developed by Anduril Industries, was also tested at PCC-4. This advanced drone is designed for autonomous surveillance, reconnaissance, and force protection. It uses artificial intelligence to detect, classify, and track objects. The Ghost X can carry up to 9 kilograms, 20 pounds, of payload and has a flight endurance of 75 minutes. Its autonomous operation means it requires minimal human control. The drone provides real-time intelligence, helping troops make better tactical decisions. At PCC-4, soldiers tested how the Ghost X could be used alongside other battlefield assets to improve reconnaissance and situational awareness. The Ghost X is estimated to cost around $250,000 per unit, reflecting its advanced AI capabilities, endurance, and adaptability. It has been tested with modular payload options, including high-resolution cameras, infrared sensors, and small precision-guided munitions, making it a multi-purpose asset. Its high-speed maneuverability also allows it to evade enemy fire, reducing vulnerability during operations. The testing of SMET and Ghost X at PCC-4 highlights the shift toward autonomous warfare and AI-driven combat support. These systems help in several ways. SMET reduces the workload on soldiers, allowing them to focus on their missions. Ghost X enhances battlefield awareness by providing real-time reconnaissance data. Both technologies increase survivability by keeping soldiers out of dangerous situations. They also make operations more efficient, improving the success of military missions. The integration of unmanned systems like SMET and GhostX is a crucial step toward reducing human exposure to battlefield risks. Soldiers can deploy these autonomous machines to scout dangerous areas, carry supplies, or provide real-time intelligence without putting themselves in harm's way. Additionally, their ability to work seamlessly with other AI-driven technologies enhances the overall effectiveness of military units. These advancements demonstrate the growing reliance on robotic support systems in modern combat, reducing operational strain while increasing mission success rates. PCC4 has shown that the future of warfare will rely on AI-powered, autonomous, and unmanned systems. The SMET and GhostX are just two examples of how technology is shaping modern military tactics. The U.S. Army is ensuring that future forces have the most advanced tools available. Autonomous warfare is no longer a concept of the future. It is happening now and is transforming how wars are fought and won. As the military continues to refine these innovations, the battlefield of tomorrow will see a greater blend of human decision-making and machine efficiency. The success of PCC4 indicates that in future conflicts, advanced robotic systems will be an essential part of military strategy, providing increased safety, efficiency, and effectiveness in combat situations. Furthermore, continued research and development will likely expand the capabilities of these systems, leading to longer operational endurance, increased payload capacities, and even more advanced AI decision-making models. The ability to deploy autonomous units in swarms for coordinated battlefield operations is already being explored, opening new possibilities for future conflicts. The U.S. Army's investment in these technologies reflects the broader military vision of a highly connected, sensor-driven, and AI-assisted warfighting environment, ensuring that it remains a dominant force on the battlefield for decades to come.